Okay, so this is Aaron Holmberg from Corvallis Middle School, and this video is about using cross-multiplying to compare, add, or subtract fractions. One of the basic ideas about fractions is that you can't accurately compare them unless they have the same denominator. And this video is all about how you see that you can always use cross-multiplying to make really accurate comparisons or to accurately add or subtract. But sometimes cross-multiplying doesn't make it as efficient. So that's a tough thing sometimes for students to learn when they should use it and when they maybe shouldn't. So anyway, when I say cross-multiplying, first thing I want to do here is I want to take this example from this particular worksheet and just show you what it means. Cross-multiplying is if you have two fractions, in this case 5/6, and you have 7/8 on this side. You can't really accurately compare them, add or subtract them, because they don't have the same denominator on the bottom. Denominators on the bottom and numerators on the top. So cross-multiplying is this process. It means that you're going to take the bottom two denominators and multiply them against each other, and that's going to make a new denominator. In this case, you can see it up here. It makes the denominator of 48. So it means each fraction becomes about 48ths instead of one about sixths and one about eighths. They're both about 48ths. Then what you do is you multiply from this denominator to this numerator to make the 40 that's up on the top there. And I'll show this again just a little bit. Because you've already multiplied this way, you don't need to do it twice, but for the sake of being symmetrical, I'll say you've multiplied this way. And you cross-multiply the other way to make the denominator on the other side, which is the 42. So let me show that one more time here. I simply could do it as I've done in this top here to be really neat. I could cross them out and write the new numbers in their places, but for the sake of it here, I'll just rewrite the problem underneath. So the new fractions become 48ths because 6 times 8 is 48. And then on top here, I have 8 times 5 is 40, and I have to write it in the same side, above the same side that it's moving in this motion here. In the cross multiplication. 6 times 7 is 42, and so I write the 42 on this side. Now if I'm comparing these, I just use one of those sort of symbols like you can see right up here on the top, one of these kind of mouth symbols. If I'm adding them or if I'm subtracting them, now I've got the common denominators and I can add or subtract my numerators to finish off the problem. This works great now on this worksheet right here. You can see that on number 1, what I just showed you, was that I replaced the 6 and 8 with 48 just by crossing them out, and I rewrote all of my new numerators and denominators right over the tops of the old ones, and I can see that 42 48ths is more than 40 48ths, and I've done that on each of them. In this case, I recognized I could have just cross-multiplied 3 times 12 is 36 for the new denominators, cross-multiply, and I've got the new numerators. 24 36ths is bigger than 21 36ths, and the same is true over here. I could multiply 10 times 12 and get 120, and I have 12 times 6 is 72, and 10 times 7 is 70, and I could see which one is larger. However, immediately here is where the next kind of problem comes. When I have 9 times 27, I could multiply these. 9 times 27, let me see. I need to make a new denominator, so let's, for the sake of it, I'm just going to rewrite this one here. 5 times 9, and I'm comparing it to 17 times 27, and I want to know, in order to make common denominators, what 9 times 27 is, so I multiply 3 and 6 and 18 and 6 is 24. So now I have 240 thirds. 240 thirds and 240 thirds. That's a really ugly fraction to even imagine. And now after I've done that, now I have to multiply 27 times 5 and 9 times 17. And really the answer here is kind of why? That would be a lot of hard work. It'll work. This will work, but it's just a lot of extra work. You've got to do 3 multiplication problems like that when you could have just noticed this. This 9 can turn into 27ths very easily. In class, I've been repeating this statement a lot. What you do to the denominator, you do to the numerator. It's a proportional relationship here. So if I multiply the denominator by 3 to make 27, then I multiply the numerator by 3 to make 15. And so rewriting this here, I get 15 27ths would be my new fraction, my new equivalent fraction here. And then I can compare that 17 is larger, 17/27 is larger than 15/27. Okay, so next door over here, 11 and 12, I don't really have much of an option. There's no common multiple that I can count by 11s and reach and count by 12s and reach, except for the multiple that is 11 times 12, and that's 132. So this one here I'm going to have to do this way. 132, 12 times 9, I'm glad I know that one, it's 108. And 11 times 10, I'm glad I know that one is 110. That wasn't too bad, it was all just math facts, and I can see that this one is larger. Now when I get back over to this one, this isn't too bad. 10 times 25 is 250. But isn't there something that I could, a multiple of 25 and a multiple of 10 that's smaller than 250? There is. I can put them both into 50. I could make 25 into 50 by doubling it. And what I do to the denominator, I do to the numerator. So I'm going to double the numerator into 20. I have to make this one times 5 to make them both 50s. So 10 times 5 is 50. And if I did 10 times 5, then this is 3 times 5, because I'm just taking the top, and 15 50ths, and I can see that this one's larger. So the hard part is that that cross multiplication always works, but as we saw in number 3 right here, it just would have made it a lot more complicated when I could have easily changed one of my denominators into the other one and left this fraction alone. So when I get to these other ones, and I